And we're live. Welcome everybody. It's day 10, double digits. It's Saturday. It's day 10 of Administrator Code 2022. So, it's a Saturday, double digits, as I just said, so maybe it's a bit tough. I don't know. But one thing I will be doing going forward is when I explain my solutions, I won't go through every single line, or I won't go through it super in depth anymore. Just because that's now beginning to take a long time, because the solutions are pretty tough. And also, I guess if you're making it this far, you probably can read between the lines, kind of understand what my Python says. So I'm really just going to be talking about my overall algorithm and idea, as well as mentioning a couple of the cool key points and tips and tricks in my code. So I won't be talking about everything, but you can always check out my code in GitHub, and that's linked in the description down below. But yeah, let's get cracking for day 10. Let's go into my coding environment. Yep, okay, and I'm ready to go. So I'll begin in 3, 2, 1. Let's go. Right, that's part 1 done. Yeah, I made a few too many mistakes, but I think I overall did that pretty fast. Yeah, just some logic errors. I was pretty happy with that. Yeah, so I'll just copy my files over, and I'll see what part 2 has in store for me. Okay, that's part 2 done. Yeah, I think that took me a bit too long. Really satisfying to get the answer though. Yeah, really simple error for part 2. But anyway, let's go on to see the question. Day 10, cathode ray tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in a screen tells you it probably won't be much of immediate use. Unless, that is, you can design a replacement for the device's video system. It seems to be some kind of cathode ray tube screen. I'm not old enough to know what this is. And a simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent to the CPU. The CPU has a single register X which will start with the value 1. It supports only 2 instructions. Add XV takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle to complete. It has no other effect. The CPU uses the instructions in the program, your puzzle input, to somehow tell the screen what to draw. In this example, maybe you can learn something by looking at the value of the X register throughout execution. For now, consider signal strength, the cycle number multiplied by the value of the X register, during the 20th cycle and every 40 cycles after that. Another example. So find the signal strength during these cycles, and what is the sum of the C6 signal strengths? Yeah, so after reading this, again, you kind of have to read the rest of it. But I think, to be honest, you can kind of skip down to this bit and just read that, and then a bit of that. But yeah, the question itself is actually really pretty easy. So let's look at my code and see what I did. Right, so taking an input. Yes, the idea is I go through every instruction in X and keep track of the cycle count separately as a different variable called Q. And T is just my answer. So I go through every instruction here, and then based on what the instruction does, I add stuff to the register XX if necessary. But no matter what, after every single cycle, I check if the cycle is one of the ones that we're meant to check, one of these ones that we're meant to check. And if it is one of these we're meant to check, then just update your running total with the correct value. And that's pretty much it. You just print T, and yeah. The only thing that took me a while here was just noticing or recognizing the fact that XX starts at 1. So register X starts at 1 and not 0. That's my only mistake. But yeah, other than that, it's pretty simple. You can see here, Q is my cycle, so I've updated it here twice before then adding the value to the register, because the value to the register is only added after 2 complete cycles. So that's what I do here, just 2 complete cycles. And like this 3 lines is essentially 1 cycle of code. Yeah, I think that's pretty much it. Yeah, that was really easy, quite like that. Let's move on to part 2. Let's see, part 2. It seems like the X register controls the horizontal position of a sprite. Yeah. Specifically, the sprite. Oh, anyone who has ever touched Scratch in their life knows what a sprite is, and I presume basically everyone here has used Scratch at some point, maybe they're not like 5. Specifically, the sprite is a 3 pixel wide, and the X register sets the horizontal position of the middle of that sprite. In the system, there is no such thing as a vertical position. If the sprite's horizontal position puts this pixel where the CRT is currently drawing, then those pixels will be drawn. You count the pixels on the CRT, 40 wide and 6 high. This CRT screen draws the top row of pixels left to right, then the row below that, and so on. The leftmost pixel in each row is position 0, and the rightmost pixel in each row is position 39. Like the other CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle, representing each pixel of the screen as a octothorpe. Sorry, what's the cloaker word? Hashtag, yes. The mathematical shape of this is actually called the octothorpe, which is why I just call it that. Anyway, here are the cycles during which the first and last pixel in each row are drawn. So by careful timing, racing the beam, again, I feel like I'm way too old to know what this means, what this references. The CPU instructions and the CRT drawing operations. You should be able to determine whether the sprite is visible the instant pixel is drawn. If the sprite is positioned such that one of its 3 pixels is a pixel currently being drawn, the screen produces a lit pixel, otherwise the screen leaves the pixel dark. This is actually such a random system of drawing stuff on a CRT. Like, maybe this actually is how they worked, but I don't know, I just feel like it's a bit random. So this is another example. Render the image given by your program. What 8 capital letters appear on your CRT? Yeah, so this is another one of those, like, letter outputting programs. Let's just look at my code. Yeah, so in the time lapse, you probably saw me trying to completely like refactor the code, and then realizing I probably should just do it this way. And I guess that's kind of the con of when you like read this last sentence and then partially skim read the rest. Because I only kind of read a bit of this, then started coding, and then went back to reading it, and then I kind of realized that the way I was doing it was a really terrible way. So yeah, and then went back to like basically my original code. Which you probably recognize here, just by going through every instruction. So what I was thinking of doing originally is going through every cycle, and not every instruction, but going through every instruction is easier. And then, yeah, pretty much the same as before, it's just instead of each cycle, so previously each cycle you would have to add to the cycle count, and then check if the cycle count is in like one of those multiples that you need to check for. What I'm doing here is what you have to do first now is you have to draw the CRT screen, and then you have to add the cycle count, and that's where I kind of made the issue. That's what sent me back like 10 minutes. I put all of these cycle counts like up here before I updated the CRT. So you know, I eventually figured out somewhere here that you're meant to update the CRT like before you increment to the next cycle, before you increment to the cycle. I guess the way I've written the code here is pretty hard to check like where this lies on the cycle, because in reality this code, like this if statement, lies at the end of a cycle, because I'm doing it right before I update to a new cycle. Whereas before, what you had is because you had the cycle update right before the if statement, you'd have this if statement occurring right to the start of a new cycle. But it's the opposite this time, and that's something which I didn't really notice, which is why I had some issues. But yeah, in terms of how the CRT screen works, it's just a simple, really long list. You can kind of ignore this code, that's just junk code from my original plan, which failed. Yeah, so I'm just creating the whole array, which is just 240 pixels. I'm going to assume they're all unlit for now, and then light them up as needed as the code progresses. Yeah, and so just some basic maths, which I completely overcomplicated and therefore again messed up. You just want to check if your current cycle, because essentially cycle corresponds to the pixel you're working on, right? Because every cycle you need to update a pixel, and so that you might as well just have the cycle correspond to the pixel you're working on. And so my cycle / pixel number here is called II. And yeah, I'm just checking if the position on the row is in that 3 element sprite. So obviously the center of the sprite is register X, then you obviously have to account for the one before it, so hence the -1 here, or the one after it, hence the +1 here. And yeah, just to check, because obviously your cycle, they go all the way up to 240. Your row per CRT row only goes up to 40, right? So you need to account for that just by, I just take the cycle modded by the length of the row, which is 40. And so that kind of just resets the row. So you're kind of automatically resetting the row every time when you compare it to X. And then once I've done that, if it is true, like if the sprite does cover your current cycle / pixel position, then you just have to update that pixel position in your list, in my like long CRT list, and update it to lit, which I just do with the octothorpe here. And yeah, pretty much the same code as before, same idea. And then just to print out the answer, because I mean technically my massive 1D array list is 240 characters long, but in reality it's meant to be like 6x4 characters long, right? It's meant to be a 2D array, but that's just too much effort. So I only turn it into a 2D array as I print it. So for I in range 6, so for every row, I'm printing out the actual row, which is this. And again, the math isn't too difficult here. You're just calculating what position of the 1D array is the start of your current row, or position of the 1D array is the end of your current row. And yeah, you just print that out. But yeah, I think that was pretty good. Yeah, again, I think I've been having problems for part 2 for the past couple of days. Just being really slow trying to update my part 1 program to do the part 2 thing. So definitely need to work on that. But otherwise, I think today wasn't that bad. It was actually pretty easy, very easy actually. A bit of thinking needed in part 2. But yeah, part 1 was definitely super easy, and I quite like that. I don't think there's much else to say about my code. Yeah, I think I've covered everything there is to know. Yeah, just be extra careful about this mod bit. Because if, for example, you're going across a row like that, let's go to the diagram. If you're going across the row like this, once you pass cycle like 39, then your I still technically continues. So you're still like going down across the entire list, right? But like register X is only within this range, because it just can only be within that range. It can't be anywhere else. But your II is just like your cycle length is going all the way beyond. So you kind of have to like reset it. So that's what the mod does. It kind of resets once you get here. Once your cycle length gets here, you kind of reset it back to here, and then compare it. You kind of you just keep resetting it essentially back to the start of the row when comparing it, because otherwise it doesn't work. I think that's where I got confused. Just yeah. Anyway, that was a really fun day. Quite like that. And yeah, I kind of like this letter idea of like you kind of have to just like try and read the letters from the image which Eric makes you create, which is really nice. But anyway, that was the code for today. That was a puzzle. Really enjoyed that. 20 stars now. So what we're 40% the way there. That's crazy. 40% the way through Advent of Code 2022. Even closer to Christmas again. But yeah, I'm enjoying my lovely 20 stars. I've seen the Advent calendar continue as I guess I'm venturing from the sea through this forest. And this is the river which I'm currently stuck in and traveling downstream or upriver, whatever. Yeah, and hopefully the elves find me at some point later. It's Advent calendar. Leaderboard. Let's go to, let's see, about 5 minutes. Wow, that's fast. Yeah, the first guy did it in 2. At least you know like AI is solving the code and getting them really fast times. Part 2, 6 minutes and what's that? 12. Ooh, and this is anonymous, the guy in our school leaderboard. Nice. Wow. Yeah, these are some really good times. Yeah, to be fair, part 2 had a lot of stuff going in it, so I can see why the times for this are so much longer than part 1. Let's check out the stats. Okay, day 7's racking up some more people pretty slowly, because we've got up to 80,000. But yeah, all of these are just progressing like pretty slowly and steadily, which is nice. And yesterday 50,000 people have done part 2, which is nice. Hopefully today that's also going to be nice and high. So let's check the school leaderboard. Yeah, I feel like these 3 are now going to kind of remain in that static position. Because Anonymous is just always so fast. Danish is also pretty fast. And then Abinau is always just right behind them. Yeah, of course. This idea is just going to continue, I reckon, for the next 2 weeks. Right, Delta times. Yeah, how? 7 minutes. I guess that's what got him onto the part 2 leaderboard. Yeah, that's fast though. And man, Dr. Danish, he did part one really fast. Yeah. At least these people took a while for part 2, which makes me feel a bit better. But yeah. Another really good day. Awesome puzzle from Eric, so thank you for that. I hope you enjoyed looking at my code, looking at me code it. I hope you Hope you managed to write your own code, which worked. And yeah, that's the first 10 days of December down. The first 10 days of admin done. And let's go on to see what Eric has in store for us tomorrow. I'll see you later.